Now we have come to the final presentation. So this final session will be presented by Mr. Anurag Dutta and Mr. Manan Roy Choudhury. So they are actually the undergraduate computer science and engineering, Government College of Engineering and Textile Technology, Srirampo, Calcutta, India. Okay, now ladies and gentlemen, please welcome them for the research paper presentation entitled A Perusal of Transaction Details from Silk Road 2.0 and its cogency using the Riemann Euclidean of integrals. Now I'll pass the session to the presenters. The floor is yours. Please welcome.
Hello everyone, I am Anurag Dutta and I will be going to present the paper of a perusal of transaction details from Silk Road 2.0 and its cogency using the Riemann elucidation of integrals. Currently, I am an undergraduate at the Computer Science and Engineering Department of Government College of Engineering and Textile Technology, Shriram. So let us begin with the paper presentation. The first slide talks about the objective of our paper. The basic objective behind our paper is to propose a new methodology, basically termed as Riemann elucidation of integrals, that is been acquainted with the data validation field. That could be used for like data validation. The name behind the proposed method is the Riemann elucidation of integrals that is been proposed by the scientists many years ago. So the applicability of the new method have been verified on the transaction data details that have been obtained from the dark web. Like we have taken the details from the dark web transactions data set that was available openly in the surface web. And from that we sliced it between the two dates, that was the November of 2015 and the November of 2017. And we just analyzed all of these details between these two dates and applied our new method on that and tried to propose that whether that was present with some kind of fallacies or not, or it was completely free of fallacy, like all those stuff. The next slide talks about introduction. Indexing the World Wide Web dates back to the early 1990s, and by the 2000, several major search engines like Google and Yahoo rose to prominence. While the size of indexed pages rose to billions, tens of billions more can't be indexed and hence are not retrieved using a search engine. These pages are quite often behind a paywall or like password protected sites, so some unauthorized web crawler can't index them quite easily. Such pages collectively constitute the dark or the deep web, while those indexed in the World Wide Web will be constituting to the surface web. Small peer-to-peer networks between friends are included in the darknets that make up the dark web, along with huge well-known networks run by individuals and public entries like Tor, Freenet, I2P, Rifle, etc. So this is a basic introduction of our paper, and these are the basic topics that we will be touching in the presentation itself. The next slide talks about cryptocurrency. So according to predictions, the market capitalization of cryptocurrency could reach 1 to 2 trillion in 2018, with peak trade volumes of almost 3 billion per day. The market capitalization of Bitcoin hit like 70 billion. According to the World Economic Forum, cryptographic protocols will be used to hold like 10% of the world's GDP by 2027. China is the home to all those equipments that are required by the miners or like mining cryptocurrencies. So, which account for like 70% of Bitcoin mining, which is a quite a great percent. Like surface web, there are a lot of sites enlisted in the dark web. One of them is the Silk Road, which is quite known for like illegal transactions, like drugs and guns, trafficking, and all those kinds of illegal stuff. In October 2013, FBI seized the website, but its mirror Silk Road 2.0 was hosted by the former administrators of the Silk Road within a month itself. So, from this, we could say that their network was quite strong enough that if some the main website got down, and within a month the mirror came up, and so we could say that it was quite strong. Like, the next slide talks about cryptocurrency. So basically, in this slide, we were talking about the Bitcoin cryptocurrency. Well, there are some other cryptocurrency like Ethereum, Dogecoin, and all those kinds of. So a cryptocurrency is basically a digital form of currency, and it is not controlled by any particular government or like institution, but it is controlled by a group of equally powered men who are referred to as miners. So the bitcoins basically work in a blockchain. So in a blockchain, bitcoins are registered at some specific bitcoin address, and to create such an address we will need a private hash value, and computing that we could reach to that corresponding address. So let us move to the next slide. The next slide talks about Zipf's law. So basically, Zipf's law is a linguistic law, or a law that have been used in linguistics quite well. But in the recent times, people have been using that for data validation. In fact, in one of a paper we just mentioned that we have used Zipf's law for validating some data sets. Like, we made use of the US 2020 elections, that was 2020 elections, and we just validated that using the Zipf's law. So let us come back to the presentation of the paper. So between the late 19th century and the early 20s, one observation that struck many of the scientists and linguists was like some words appeared to be found more frequently than others. So the American linguist G.K. Zeff first explained it quantitatively. Previously, it was explained in qualitative manner, like some was greater and some was lower, like in this manner. But Zeff first sought to explain it quantitatively. He said that there exists a inverse kind of relationship between the frequency and the rank. He stated that the product of frequency and rank is always going to be a constant value. So mathematically, we could say it like f of r cross f will be equal to c square, where c square will be a positive value and r is the rank, and fr will be the frequency corresponding to that particular rank of r. In this slide, we will be talking about the proposed methodology. So if we consider the rank to be acquainted along the x-axis and the frequency to be along the y-axis, and their 2D plot will be a rectangular hyperbola with the x and the y-axis along their asymptotes. So like phi of x cross x will be equal to c square. Now the set of discrete points within the domain will be corresponding to phi x, like 1 comma phi of 1, 2 comma phi of 2, 3 comma phi of 3, like all those. Considering the discrete points, the total area that we could get is like half of sigma, that will be going from 1 to 8, phi I plus phi of I plus 1. And by evaluating the area by making use of the Riemann elucidation, we will be finding it like integration 1 to 9 c square upon x dx, which is basically a rectangular hyperbola. The name. Further, we would be like equating them to reach to a proposition. So by equating them, we get 2 times the sum of all of these discrete values. So will be equal to 2 times c square log base e of 9 minus sum of the first frequency and the last frequency, that is phi of 1 plus phi of 9, which could be just simplified as the summation of all of them added with some kind of error like epsilon, that will be equal to c square log of 9 plus 5 upon 9. Thus, the relative difference between these two areas would be c square 0.0761, and the relative rating percent will be 2.690%. So that's it. And from the next slide onwards, we will be performing some mathematical analysis on the basis of the proposed methodology that we have discussed about in this paper. And I would like to request my co-author Manan Choudhury to continue the presentation from this slide. Thank you.
Hello, my name is Manan Choudhury and I am going to continue this presentation from the part Mathematical Analysis. We would like to analyze the darknet dataset used by Gwen Barnwell. We have compressed the dataset to a certain limit for our betterment in our research purposes. We have considered both the price in USD and the price in BTC for our analysis. BTC basically means the Bitcoin price. We have considered some items. The items are as follows: Ray-Ban Tech Aviator Flip Out Sunglasses Replica, Ray-Ban Aviator Classic Sunglasses Replica, Rolex Watch Box, Ray-Ban Clubmaster Sunglasses, Rolex Submarine Two-Tone Black Replica. Now the price in BTC and the USD is on the screen. You can see the prices as mentioned below. Considering the discrete area for the prices in USD, we have got it to be 399,574.5 square units. We have got this area by calculating the areas under each trapezium of the graph. Now considering the continuous area for the prices in USD, for this we have used integration, the area under the curve. The area we have got is 282883.8754 square units. So coming to the relative error in area, that is del epsilon divided by epsilon, this gives out to me 29.292037216. Now this is unacceptable, and it is unacceptable. We have mentioned this in the proposed methodology part why this relative error is unacceptable to us. Now from this analytics, we can conclude that the prices in BTC is a better mark than the prices in USD, because the relative error in BTC is much less than the relative error in USD. One logical explanation for the surging height of the relative error in USD is because of the rise and fall of the government controlled currencies. Here it is USD. Now bitcoins are not controlled by any foreign bodies. It is controlled by individual bodies. We can say that that brings the price stability to BTCs will be much higher than that of the USDs. Now to validate our Riemann elucidation of integrals hypothesis, we will make use of Zipf's law that links the rank of the first digit of the inputs with the corresponding frequencies. Basically, when observations are ordered according to how frequently they occur, this law states that the frequency of a specific observation is inversely proportional to its rank, or frequency is inversely proportional to the rank, to be precise. To display more details in the extremities, a log-log graph is employed. Now coming to the part, what is a log-log graph? A log-log graph serves a rank as the scale of the horizontal axis, and the log of the frequency serves as the vertical axis. Plotting the logarithmic plots including rank and frequency, we get nearly a straight line. Now, this observation helps us in concluding that the dataset is free from any fallacies. Theoretically, the log-log graph should be a straight line with a negative slope. Plotting the logarithmic plot, including rank and frequencies, we get nearly a straight line curve. This observation helps us in concluding that the darknet dataset is free from fallacies, and it is true theoretically, not always practically. Now this is the graph for the log-log curve for the price in USD. You can see it is almost a straight line with negative slope. This is not an ideal case, so it will not be totally a straight line, but you can see the image nearly corresponds to a negative slope straight line. Similar for the BTC price. Now here you can see the difference in the graph. This graph is more of a straight line than that of the previous graph. This follows the Zipf's law more betterly, or our law means the Riemann hypothesis law. This follows it more better than the USD price and USD curve. and we have also stated the reason why it follows it better. Now coming to the conclusion part, the formula highlighted and is derived in this paper differs and takes advantages, many advantages over Zipf's in a few key ways. Now some of the advantages are Zipf's does not state whether a dataset is valid or not because there is no estimate for the confirmation range under which we can declare a dataset to be theoretically valid or invalid. Similarly, the absence of error limitations in Zipf's prevent us from determining the acceptable level of dataset departure from the ideal scenario. These are two main problems by which we get many fallacies in these theoretical laws and often proves to be wrong in practical situations. In the next slide, we will discuss about some few scopes of further research in our formula. This conjecture can be given a confirmation range for absolute percentage error. We have not done in this paper, and if the absolute percentage error of a particular dataset falls within this range, we can say that the conjecture is theoretically valid. It is not purely established that value of the absolute percentage error is independent from the term c square. Rather, we have taken an approximation to make the expression independent of c square. Now further research on this hypothesis can be done if it is shown that the statements immediately adjacent to are all accurate. These are the references we have used for writing this research paper. Thank you. Thanks a lot.
All right, thank you very much to Mr. Anurag Datta and Mr. Manan Roy Choudhury for the presentation. All right, ladies and gentlemen, we will continue to the question and answer session.